Hello, everyone. Welcome to the Introductory to AI and Machine Learning course by Ian, Hawk, and Viraj Reddy. So for the course curriculum, this is a course that just introduces you guys to artificial intelligence, machine learning, and how both on concepts and how to code. So basically, this is a 6-week or 6-lesson course. You can do one lesson a week, or you can do it in 6 days, however long you like, however long it takes you. But it's basically split up into 6 lessons. First lesson is just today, which is just an introduction to artificial intelligence and machine learning at a basic level, just introducing the concepts, definitions, and some basic terms you need to know. And then for week 2, we'll dive right in. We'll get into overview of machine learning concepts. So not deep learning, but basic machine learning concepts and basic machine learning algorithms. And we'll also go through some code examples. In week 3, we'll really get into deep learning, and we'll talk about what deep learning is, how deep learning works, and the importance of it. And then week 4, we'll talk about convolutional neural networks, which are a type of neural network and in deep learning. So we'll learn about that, the theory and the concepts behind that. And then week 5, we'll actually code a neural network in Keras, which is a machine learning package library in Python. And then lastly, in the last week, we'll introduce natural language processing, which is another type of another field of machine learning. And then lastly, in classes 7 to 8, you guys can do independent projects. We have a bunch of projects to list out, and we'll talk about that more when we get there. And one important note is our GitHub repository is github.com/intro course AIML/lesson materials. You guys should definitely check this out because this has all the notebooks that we're going to use and all the lessons and code and everything that we're going to use for this course. So you guys should check that out. You should star the repo and share it with anyone you know. And for any updates, you should definitely check out there. We'll have all the YouTube links and everything there as well. So week 1, intro to AI and ML. That's what we'll talk about this week.
All right, so to succeed, you're probably going to need some familiarity with computer programming. Artificial intelligence is a very advanced topic, so we would definitely recommend brushing up on basic computer programming. We're going to be using Python in this course. If you're a bit rusty with Python or not familiar with it, you should still be fine as long as you have a basic grasp of the principles of computer programming.
So we'll just play a real basic introduction video for you guys to understand, and we'll talk about it after.
Every day, a large portion of the population is at the mercy of a rising technology, yet few actually understand what it is. Artificial intelligence. You know, HAL 9000 and Marvin the Paranoid Android. Thanks to books and movies, each generation has formed its own fantasy of a world ruled, or at least served, by robots. We've been conditioned to expect flying cars that steer clear of traffic and robotic maids whipping up our weekday dinner. But if the age of AI is here, why don't our lives look more like the Jetsons? Well, for starters, that's a cartoon. And really, if you've ever browsed Netflix movie suggestions or told Alexa to order a pizza, you're probably interacting with artificial intelligence more than you realize. And that's kind of the point. AI is designed so you don't realize there's a computer calling the shots. But that also makes understanding what AI is and what it's not a little complicated. In basic terms, AI is a broad area of computer science that makes machines seem like they have human intelligence. So it's not only programming a computer to drive a car by obeying traffic signals, but it's when that program also learns to exhibit signs of human-like road rage. As intimidating as it may seem, this technology isn't new. Actually, for the past half a century, it's been an idea ahead of its time. The term artificial intelligence was first coined back in 1956 by Dartmouth professor John McCarthy. He called together a group of computer scientists and mathematicians to see if machines could learn like a young child does, using trial and error to develop formal reasoning. The project proposal says they'll figure out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. That was more than 60 years ago. Since then, AI has remained for the most part in university classrooms and super-secret labs, but that's changing. Like all exponential curves, it's hard to tell when a line that's slowly ticking upwards is going to skyrocket. But during the past few years, a couple of factors have led to AI becoming the next big thing. First, huge amounts of data are being created every minute. In fact, 90% of the world's data has been generated in the past 2 years. And now, thanks to advances in processing speeds, computers can actually make sense of all this information more quickly. Because of this, tech giants and venture capitalists have bought into AI and are infusing the market with cash and new applications. Very soon, AI will become a little less artificial and a lot more intelligent. Now the question is, should you brace yourself for yet another Terminator movie live on your city streets? Not exactly. In fact, stop thinking of robots. When it comes to AI, a robot is nothing more than the shell concealing what's actually used to power the technology. That means AI can manifest itself in many different ways. Let's break down the options. First, you have your bots. They're text-based and incredibly powerful, but they have limitations. Ask a weather bot for the forecast, and it will tell you it's partly cloudy with a high of 57. But ask that same bot what time it is in Tokyo, and it'll get a little confused. That's because the bot's creator only programmed it to give you the weather by pulling from a specific data source. Natural language processing makes these bots a bit more sophisticated. When you ask Siri or Cortana where the closest gas station is, it's really just translating your voice into text, feeding it to a search engine, and reading the answer back in human syntax. So in other words, you don't have to speak in code. At the far end of the spectrum is machine learning, and honestly, it's one of the most exciting areas of AI. Like a human, a machine retains information and becomes smarter over time. But unlike a human, it's not susceptible to things like short-term memory loss, information overload, sleep deprivation, and distractions. But how do these machines actually learn? Well, while it may be easy for a human to know the difference between a cat and a dog, for a computer, not so much. You see, when you're only considering physical appearance, the difference between cats and dogs can be a little gray. You can say cats have pointed ears and dogs have floppy ears, but those rules aren't universal. Between tail length, fur texture, and color, there are a lot of options, and that means a lot of tedious rules someone would have to program manually to help a computer spot the difference. But remember, machine learning is about making machines learn like humans, and like any toddler, that means they have to learn by experience. With machine learning, programs analyze thousands of examples to build an algorithm. It then tweaks the algorithm based on if it achieves its goal. Over time, the program actually gets smarter. That's how machines like IBM's Watson can diagnose cancer, compose classical symphonies, or crush Ken Jennings at Jeopardy! Some programs even mimic the way the human brain is structured, complete with neural networks that help humans, and now machines, solve problems. Generations have long imagined the ramifications of AI, visualizing a society where machines seek revenge and wreak havoc on human society. However, the more logical and pressing question is, how will AI affect your job? Will it make your work obsolete? Just like the Industrial Revolution, it's not human versus machine, it's human and machine versus problem. The point is that artificial intelligence helps you accomplish more in less time, taking on the repetitive tasks of your job while you master the strategy and relationships. That way, humans can do what they do best: be human.
All right, so like the video said, AI is not what we stereotypically think of it as robots taking over the entire world. And AI is already in use everywhere that we look. So from whenever you go to Netflix, for example, and it tells you some search recommendations, that is using AI. Whenever Google is able to learn from your behavior and give you the best search for you, that is AI. Whenever your phone and Siri talks to you, again, AI. And wherever you look, AI is present. And so the whatever we think of it as in media and whatever, that is not what AI actually is.
So I guess what really is AI? So the standard definition that you'll find when you kind of look it up is AI is the simulation of human intelligence in machines that are programmed to think and act like humans. So basically, it means that a program learns from its own results and uses thousands of tests to gradually get closer to its goal. The program mimics how humans gradually learn from their surroundings by doing the same in their virtual environment. So if we think of like the toddler example we saw in the video, when a toddler sees like a new task, such as like trying to fit little like shapes into a hole, it knows that, hey, if I put the square into the circle and it's not going to fit, and it keeps trying and trying and trying, and it starts trying other ones, and then it finally figures out that, hey, once it gets through the square shaped one, that's when I get it right. So then it learns. So basically, the AI also learns the same way. It does trial and error, and basically tries a bunch of different things, and finally figures out what it needs to do based on its goal, which whoever's programming the AI can define. And instead of having like, I guess, like toy shapes, you'd basically have a bunch of data, and you'd have that data, and you try to achieve a goal with it. And as we talked about before, there's multiple types of AI which are used in different situations. The main ones you'll need to know are computer vision, which is just understanding images. So it doesn't necessarily mean like robots or something like actually using like vision systems, but it's more of just like computer vision just stands for basically any sort of image slash video analysis. Natural language processing, or NLP, for understanding human communication such as speech and text. So that would be such as like Google search engines or um, like Alexa and Siri. And then there's also many other types, but those are the main ones you'll need to know. So in terms of AI and machine learning, you guys have probably heard them kind of be used interchangeably, but in reality, they're not really that interchangeable. The definition of AI is the simulation of human intelligence in machines that are programmed to think and act like humans. While, as we just discussed, while the machine learning definition is the practice of using algorithms to analyze data, learn from that data, and then make a determination or prediction about new data. So as we can see in this Venn diagram, we can see that artificial intelligence is the broad overlying field. And then inside of artificial intelligence, we have machine learning. So machine learning is a subset of artificial intelligence. And as we can see in the definition, it says artificial intelligence is any technique that enables computers to mimic human intelligence. Machine learning is a subset of AI that includes abstruse statistical techniques. It's basically using statistics and data analysis that enables machines to improve at tasks with experience. And then inside of that is deep learning, which we'll talk a few lessons into the course. Um, and this is basically the subset of learning composed of algorithms that permit software to train itself to perform tasks like speech and image recognition by using multi-layered neural networks, which are basically algorithms that kind of are built based on the brain's composition. So I guess we'll quickly play a video of just a brief history of artificial intelligence so you guys get a better idea of how it works.
While everyone seems to be talking about artificial intelligence these days, it's good to remember that this is not something new. In 1950, Alan Turing proposed the Turing test. That same year, Isaac Asimov proposed the 3 laws of robotics. In 1951, the first AI-based program was written. In 1955, the first self-learning game-playing program was created. In 1959, the MIT AI Lab is set up. In 1961, the first robot is introduced into GM's assembly line. 1964 saw the first demo of an AI program which understands natural language. In 1965, the first chatbot, Eliza, was invented. In 1974, the first autonomous vehicle is created at Stanford AI Lab. In 1989, Carnegie Mellon creates the first autonomous vehicle using a neural network. In 1997, IBM Deep Blue beats Garry Kasparov at chess. In 1999, Sony introduces Aibo. That same year, the MIT AI Lab's first emotional AI is demonstrated. In 2004, DARPA introduces the first autonomous vehicle challenge. In 2009, Google starts building a self-driving car. In 2010, Narrative Science's AI demonstrates the ability to write reports. In 2011, IBM Watson beats Jeopardy champions. That same year, Siri, Google Now, and Cortana become mainstream. In 2015, Elon Musk and others announce a $1 billion donation to OpenAI. In 2016, Google's DeepMind defeats Korean AlphaGo champion. In 2016, Stanford issues the AI 100 report. In 2016, UC Berkeley launches the Center for Human Compatible Artificial Intelligence. As you can see, AI is not new. But the advances we are making are progressing at an exponential pace, leveraging our ever faster computing power, the explosion of digital data, and the speed of communication infrastructure. In some ways, the commercialization era of AI has just begun, and it will profoundly affect our world as we know it. Similarly, or possibly more profoundly, than the way the internet and mobile phones have done so before. Don't miss the next AI breakthroughs and subscribe to the weekly Applied Artificial.
Sorry. So like the video said, AI was formally founded about 60 to 70 years ago in 1956 at Dartmouth. And one of the biggest milestones for AI was when IBM's Deep Blue machine beat Gary Kasparov in a chess match. And that kind of vaulted it onto the world stage. It made it become really widely known that a computer could actually beat a human at chess. And then in 2011, something very similar happened with Jeopardy, where Watson, which is actually still being improved today, beat the reigning champion in Jeopardy. And again, AI made a huge splash.
So again, the types of AI we kind of talked about earlier, and you guys can check out these links. We'll link the slides in the description, but we'll quickly cover them. So the first one is computer vision, which is just anything that relates to image processing. So that would include, I guess, like one example would be taking in images of like animals and predicting what kind of animal it is. Another one that's been growing recently is called medical image analysis, which is basically doing diagnosis through diseases through images. So you could diagnose things such as lung cancer through lung images, and you can diagnose like bone fractures through like processing CT. Another one is natural language processing, which is probably more widespread in your daily lives. That includes like Siri, Google search engines, Alexa, anything that basically takes in text and makes a prediction or something off that. So when you ask Siri a question, it predicts the answer based on the data that it's learned from. And then recommendation systems are another type, which you guys have probably been seeing a lot, such as YouTube's like recommendation algorithm. When you guys go to YouTube and you guys go to your homepage, there's a bunch of recommended videos based on a bunch of other videos you've seen. So basically, those types of algorithms, they learn from your past watch experience, your past watch history, and it makes predictions on what related stuff that you would probably want to watch. And same thing in Netflix and other situations like that. And then the last type that we'll talk a lot about is deep learning. And again, as we talked about, deep learning is the basically the field of machine learning that creates algorithms and models that are based off the human function of like neurons and neural systems.
All right, so like we brought up earlier, AI is again used a lot in your daily life. Some of the big fields that it's used in are healthcare, so automatically diagnosing an illness or looking at MRI scans. Also sustainability and business. Business, it's used a lot for business and economics. Actually, it's used a lot for like stock predictions, figuring out what the market will look like the next day, and basically anything you can think of, AI will play a part in it.
So one thing you guys have probably heard of, if you have learned anything about AI, is the ethics of AI. So right now, since AI is, as we discussed earlier, it's not necessarily new, but it's been getting in the mainstream a lot, and now it's being used a lot more. But as all new things, there's not much regulation surrounding AI, and there's various types of ethical questions that will arise on how far to take this technology, and especially with AI, because there's so much prospect and potential with it. There's so many different applications, and there's no regulation right now. So there's a lot of discussion about AI and about the ethics of AI. So one article you guys can read that if you guys go to the slides and check it out is this Stanford article on summarizing some of the basics of ethics of AI. And some of the big questions we have to answer are, how can we ensure a right to privacy and knowledge of surveillance? So since we're using lots of data, how do we ensure data privacy? Because some people have their own data that they don't really necessarily want to share out because it's their own. So how do we kind of make sure that that's private and it's not getting shared to the wrong people? Another thing is, will AI ever be able to do things on its own, like entirely on its own, in the sense that like it can learn things without a human programming it to learn those things. And like one far-fetched example that just kind of explains what it would be like is Ultron from Avengers. If you guys ever watched that movie, you guys remember? I think it was the second Avengers movie. Ultron was this robot that Tony Stark basically created through AI, and basically it learned how to do things on its own, and it became really problematic. I don't think that's ever going to happen in our world. I don't think anyone thinks it's going to happen, but it's just something to think about. Something like that. Like, what if we had an AI that could start doing things on its own, and then how would that really impact the world? Another is how will AI impact employment and jobs, such as since we can now automate a lot of jobs, such as cashiers and like manufacturers in factories. How can we make sure that these jobs are not being taken away at too high of a rate and hurting people in their lives because they don't have jobs? And then lastly, who do we hold accountable for AI? Let's say an AI messes up. Let's say a self-driving car basically hits a pedestrian. Who's responsible for the actions when an AI malfunctions, or even not even malfunctions, but just makes a wrong prediction, right? Let's say we have a medical diagnosis and we're using AI, and then it gives a wrong diagnosis. How do we? Who's responsible for that? Like, is it the developer? Is it the one who's using the AI? There's lots of these questions that we don't really know how to answer, and there's a lot of ethicists that need to grapple with these right now. So here's a quick video on how the ethics of AI and how it could hurt your employees.
Some companies will use AI to obliterate yours. When the internet became big and viable for businesses, both Macy's and Amazon used it, just in different ways. Macy's created a portal for people to shop at their store. Amazon created a completely new business model of shopping. While Macy's had retail stores with employees to pay, rents to pay, and lights to keep on, Amazon had none of this to worry about. They could save money and offer a broad range of products. The difference is that Macy's integrated the internet, while Amazon used it as a foundation for their business model. So some of you are asking, what's the big difference? Well, think of it this way. What happens if you pull out the internet? Make it disappear. Amazon will cease to exist, but Macy's will still. Because the difference is that Amazon uses the internet as its foundation. Companies are wrestling with the same problem now, just with a different technology, artificial intelligence. So let's think about Macy's and Amazon's in this new world. Here's how a company works. It makes products or designs services, which is the operational part of the business. Then it offers these products and services to their customers who pay for it. The company also gathers data about a bunch of other things like products, customers, operations, metrics, and pretty much anything else that they plan to use or use. The company could insert AI on the customer side to offer things like chatbots, use it in their business processes for improvement, or use it in their data to make predictions. If Macy's were to use AI, that's how they would probably do it. On the other hand, think of a new Amazon being created, but it's going to use AI at its foundation. So what are some possibilities here? First, let's see what AI can do today. It can recognize objects and images, can model complex rules with data sets, and can process large amounts of data to find underlying patterns, among other things. The new Amazon could use AI for these tasks. In some cases, AI will replace people, and in others, AI will simplify processes. Here's a tangible example. We all buy insurance. The premium we pay for the car is proportional to the risk. If we live in a bad neighborhood, we pay more. One company could specialize in risk by gathering data from multiple sources, such as credit agencies, crime reporting agencies, weather companies, people data, and others, to compute a risk score on you and the car. Internally, they use AI to digest all this data and create models. Just like how companies can check the credit history of a person, these companies can offer risk scores to other companies. Now, risk is only one part of insurance. What about quoting, billing, payments, and claims? Now, imagine that multiple companies sprout up and each one specializes in one part of this whole process. This is a completely new business model for insurance, and each company has a specific role to play in this big ecosystem. Maybe another AI company will simply orchestrate the connections among the new ones to provide an end-to-end experience for the customer who doesn't need to know what's behind the scene and that a bunch of companies are working together. So this is serious competition. If your company's business model is outdated, it can't compete. Like Macy's that's having a tough time against Amazon. It's not the problem with the people at Amazon being too smart or working harder. It's the business model that makes this huge difference. Thanks for watching, and if you like this video, please give me a thumbs up and consider subscribing.
So data is extremely important, especially for machine learning, which is what we're going to be covering a lot of in this course. So like we said before, machine learning operates off of being able to improve over time with more exposure to more data. So you see more of some data, and you're able to gradually make your program better off of that. And so there are questions with data, but in general, the more data you have, the better your program will operate. And one of the best resources for data, one of the best public resources, I should say, is Kaggle. So Kaggle has about 50,000, I believe, data sets on basically everything you can think of. And we're going to be using a lot of it in this course. So you should definitely be familiar with it.
So I guess you guys, since you guys are mostly younger students, probably in middle school or high school, you're probably wondering how will AI help me? Why should I learn about it? So some main things in terms of college applications and college and future work. There's potential majors in CS and engineering, and if you guys want to major in STEM, CS, engineering, then you probably want to learn AI because it's going to be really big in the future. And a lot of your classes that you can take could be AI-based classes, such as machine learning courses and AI courses. So it'll be really useful there. There currently is no AI or ML major. There's a data science major at some colleges, but it might be a thing in the future, in the near future, actually. So I think if you guys are interested in kind of future careers or your future education, this is something that will really AI will really help you out there. And then AI in your future careers, every career is kind of gradually integrating AI and developing a foundation in AI that'll assist you wherever you choose to go. Regardless of what you want to pursue, AI will most likely be helpful and important, such as Viraji wants to be a doctor. And in the future, a lot of doctors are going to be learning how to use AI because of its vast potential and application in healthcare. And these are the various reasons as why you should learn AI and why it'll help you. So Google Colab, Google Collaboratory is basically a free integrated development environment, IDE, hosted by Google that allows you to run your Python code. And it's specifically made for machine learning, and it's really good for machine learning and AI and data science. So here's a quick video on how we can set that up. Going forward in this class, all of our notebooks and all of our code is going to be held in Google Colab notebooks. A notebook is basically like a different type of Python file that basically you'll see in this video. But we're going to run all our code in there, and all our code is in our repository in GitHub is shared in a notebook file. So you guys should definitely learn how to use Google Colab. So here's a quick video on how to use it and explaining it.
Hi, and welcome to this video series on Google Colab. I'm Jake Vanderplas, and I'll be your guide today as we look at what Colab is all about. Google Colab is an executable document that lets you write, run, and share code within Google Drive. If you're familiar with the popular Jupyter project, you can think of Colab as a Jupyter notebook stored in Google Drive. A notebook document is composed of cells, each of which can contain code, text, images, and more. Colab connects your notebook to a cloud-based runtime, meaning you can execute Python code without any required setup on your own machine. Additional code cells are executed using that same runtime, resulting in a rich interactive coding experience in which you can use any of the functionality that Python offers. For example, here we define a variable containing a range of 10 numbers. In the next cell, we loop through this range, printing the square of each number. For convenience, we use the Shift-Enter shortcut rather than the play button to execute the cell. Cell outputs are not limited to simple text, however. They can contain any number of dynamic, rich outputs. For example, we can search Colab's built-in library of code snippets and insert code to create an interactive data visualization. This particular visualization is created with Altair, one of several third-party visualization libraries that Collab supports. Collab notebooks can be shared like a Google Doc, and for this purpose, it's useful to use text cells to provide a narrative around the code you've executed. Text cells are formatted using Markdown, a plain text document format that's rendered on the page. Markdown format is simple and powerful, allowing you to add headings, paragraphs, lists, and even mathematical formula. If you would like to share your notebooks with others, you can do so via Google Drive sharing, or even by exporting your notebook to GitHub. The notebook is stored in the standard Jupyter Notebook format, and so the notebooks you create can be viewed and executed in Jupyter Notebook, Jupyter Lab, and other compatible frameworks. The convenience of sharing notebooks means that you can find and explore many interesting notebooks around the web. One useful collection is the SeedBank project at research.google.com/seedbank. For example, the Neural Style Transfer seed shows how to use deep learning to transfer styles between images, and includes a link to a Collab notebook where you can run and modify the code. To learn more about Collab, visit collab.research.google.com and find the Welcome Notebook, where you will find links to tutorials and other info about Jupyter and Collab notebooks. You can also find the remaining videos in this series, which will explore Collab in more depth. In the next video, my colleague
So hopefully that kind of introduced you how to how Google Colab works. You guys should rewatch the video if you guys didn't catch completely. Well, in the slides, you can just check out the link. And it's going to be super helpful that you learn how it works, because this is how we're going to run all our code. And another important thing you're going to need to know is how to use GitHub. GitHubs are going to be our primary source of storing and sharing code and materials for this course. If you guys go to that GitHub link we put at the beginning of the slides, that's where we shared all of the notebooks for every lesson. It's already all there, so you guys can just check it out on your own. And whenever we do code examples, and all of our lessons are actually going to be going forward, are going to be in notebook format. It's not going to be slides anymore. So you guys can just follow along and have those open as you watch the videos. And all you should make sure your GitHub account should make GitHub accounts if you don't have them. And we're going to teach you how to share code on GitHub using GitHub Desktop. It's in this video. We'll link this video in the description. It's kind of long, so you guys probably need to watch it on your own. But it's going to be really important that you know how to use this, because obviously, one, you do want to store all your code on GitHub because you don't want to lose your code. But two, you guys should add it to just when it's open, you guys can share your code and it shows like the work you've done.
Okay, so in Python, we're going to be using these libraries a lot. So just as a refresher, a library is basically something in Python where you have a bunch of predefined functions that you can use instead of writing out these codes all the time. So NumPy will basically go over working with it's basically working with numbers, so arrays, manipulating those. Pandas is working a lot with data. So for example, putting them into CSVs, transitioning a bunch of tables, that kind of thing. Matplot is your ability to graph data. So it's used a lot for visualization. And then the other three, TensorFlow and Keras, PyTorch, and scikit-learn, are all really important machine learning libraries that we're going to use.
Lastly, here's just some homework for you guys before we enter our lesson. You guys should brush up on your Python. We're not going to actually go over like an intro to Python in this course. It's kind of like a prerequisite. You guys should learn some basic syntax because it's pretty important to learn Python, because all of our code is going to be in Python. All the libraries we use are in Python. So you don't have to have like full experience with Python, but as long as you understand the basics of coding, specific loops, variables, all those things, you'll be fine. Just make sure you kind of just review some of the basic syntax. Python is actually a pretty easy language to learn because the syntax is really simple. You don't have to learn a lot of things that you have to learn in languages such as Java. So you guys should be fine. Just check out some of this reference centers and some basic links. We'll share them in the description as well. And then also check out this link on how to use Python with Google Colab. And then you should also check out these intro notebooks and learn how to use them. And there's going to be some really basic introduction files and just commands and stuff. So if you guys have any questions, just leave them in the comments of the video. We'll answer them really quickly. You guys can also create an issue on GitHub, on our GitHub repository. This will be the quickest way to respond. We'll respond there the quickest. And you guys ever have any code issues, you can just copy and paste your code there, and it will be really easy and nice to read. And lastly, we would really love if you guys would join the GitHub organization. You guys can follow along with our code and upload your code in your own repository and share it with the rest of the members in the course. And to be invited, just create an issue on our main repo or just shoot one of us an email at these two emails right here. And that's it for today. Hope you guys enjoyed. If you guys learned a lot, and stay tuned for episode 2 or lesson 2, and we'll just basically go into really basic standard machine learning theory.